So we are still in block 1, general physics, and today we'll start topic 1.3, which is mass and weight. So it's a short topic and we will complete in one session only. The learning objectives, what are the learning objectives? You should show a familiarity with the idea of the mass of a body, means what is the concept of the mass, and state the weight is a gravitational force, and the distinguish between mass and weight, the difference between mass and weight, and the equation which can relate mass and weight, which is W is equals to mg, and demonstrate understanding of the weight, and hence mass can be compared using a balance. So using a balance, we can compare masses and weight. This is a learning objective. Now we'll start our first topic, which is the mass of an object. So how you define a mass? Anyone having idea? Abdullah Khan, Abdullah Safras, Afreen, Hatib. How you define mass of an object? You can use your mic. The definition of mass. Any idea? The concept or definition of mass. Any idea? How you define mass of an object? Yes, Saim. So mass is basically amount of the matter. How much matter is there? So it is a measure of the matter in a body, or how many particles are there basically, how many molecules are there, how many atoms are there. That shows the mass of an object. Like example, I have two objects, and object A is having 4 particles and object B is having 8 particles. So which object is having greater amount of matter, A or B? Which object is having greater amount of matter in it, A or B? So basically B is having greater amount of matter, B is having more particle, and the number of the particle or amount of matter refers to the mass of an object. So this is having more matter, number of the particle, this is having less matter. So when we compare the mass of the object, which object will be heavy, A or B? Which object will be heavy? So object B will be heavy and object A will be lighter. So a simple concept of the mass, it is amount of the matter. Is it clear? The definition of the mass? The amount of matter in a body is simply known as mass of an object. And we normally represent the SI unit of mass as kilogram. Like example, if I say this was 2 kg, but this will be example 5 kg. So greater the amount of the matter, greater the number of the particle. Yeah, so more matter refers to more mass of an object. So mass is a measure of matter in a body. And what is the SI unit of the mass? The standard or system international unit, that is kilogram or kg. But there are other units such as gram, milligram or ton. But the SI unit is kilogram. And how we can measure the mass? Mass can be measured by a beam balance or electronic balance. Maybe you have seen this type of balance in our lab also. You have seen this is called a triple beam. This is a beam balance, or this is the electronic balance. So when we place the object on the balance, we can the reading on the balance shows the mass of an object. Or we can also use this beam balance to measure the mass. Or there's also another way, another type of beam balance which is very common. For example, if you are buying a kilo of potatoes, so how you identify that it is 1 kg? So a seller will place a mass of 1 kg on one side, and he will place the object, like in this example potatoes, on the other side. When the beam is balanced, beam balance means when it is exactly horizontal, it means mass of this object is also 1 kg. So this is a very common beam balance which is also used to measure the or compare the mass of an object. Is it clear, the concept of the mass? So mass is measured matter in a body or amount of matter in a body. The SI unit is kilogram, and it can be measured by a beam balance or an electronic balance. This is also a beam balance. This is also a triple beam balance. This is a simple beam balance, but both are. So example, if I place 1 kg here and another pen I place an object. So my question is, the mass of this object is equal to 1 kilogram, more than 1 kilogram, or less than 1 kilogram? Mass of the object which we place on the right hand side, is it more than 1 kg? Because on the left hand side we place a mass of 1 kg, on the right hand side we place an object. The mass of an object is more than 1 kilogram, less than 1 kilogram, or equal to 1 kilogram? That's the question. So what could be the right answer here? On the left hand pan you place 1 kilogram object, on the right hand side there is unknown object, and the question is, what could be the mass of this object? Is it less than 1 kg, it is more than 1 kg, or it is equal to 1 kg? On the left hand side you have 1 kg, okay? On the right hand side there's unknown object, and the beam tipped more towards 1 kg. So my question is it more than, the mass of this object is more than 1 kg, less than 1 kg, or equal to 1 kg? So the correct answer is, it is less than 1 kg. Why it is less than 1 kg? Because on the left hand side 1 kg, the pan tip more towards 1 kg, so means this object is lighter. If both objects having the same mass, then what happened, the beam should balance. So if both were having the same mass, then how it should appear? So when we place 1 kg object here, or 1 kg mass, known mass, and then we place an unknown object, and the beam is balanced, beam is horizontal. So in this example we can say that this object mass is equals to 1 kilogram. So a beam balance can be used to compare the masses of an object. So the side where the beam balance tip, that side is having more mass. Is it clear, the concept of the beam balance, which is used to compare the masses of the objects? Another example related to the beam balance, which is used to compare the masses of the object. This is a beam balance. And we place, say, 2 kilogram here. On the left hand pan we place a known mass of 2 kilogram, and on the right hand side we place an object. So on the right hand side we have an object. My question is, what is the mass of object? Is it equal to 2 kg? Option A. Is it less than 2 kg? Or option C, is it more than 2 kg? So what could be the right answer, A, B or C? Is it equal to, less than? So the correct answer for this one, it is more than 2 kilogram. That's why the pan tipped more towards the object. So object weight is more than 2 kg. So a beam balance can be used to compare the masses of an object. Then mass of an object remains same throughout the universe or remain constant. Like example, say this is the earth, and you have example a moon, and you have an object which is having, say, 4 particles. This is just an example, and the mass of this object is equals to 2 kg. Now what we did, we took the same object to the space and then we placed that object on the moon, on the surface of the moon. The number of the particle does not change, it remains 4. So question is, what happened to the mass of an object? It will be more than 2 kg, less than 2 kg or equal to 2 kg on the moon. So you have object, mass means amount of matter. As the amount of the matter does not change, because mass refers to amount of matter, so as the amount of matter does not change, the mass of an object does not change, so it will remain 2 kilogram on the surface of the moon. So even if you place this object in space, as the number of the particle does not change or number of the particle remains same, so the mass will remain same, so this mass will remain as 2 kilogram. So basically the mass of an object does not change from place to place, it remain constant because it is the amount of the matter. So if the number of the particle or amount of matter remains same, the mass of an object does not change. But it can change if the amount of matter is changing. For example, you have a container which is filled with water, and the mass of this water, example, 0.2 kilogram. Now you left it for a week, So you left this a glass of water for a week, and what you observe evaporation happen, evaporation occur, and due to the evaporation, the amount of the liquid decreases. So my question is, what will happen to the mass in this example? It will be equal to 0.2 kilogram, more than 0.2, or less than 0.2, the mass of the water, because in the beginning we were having 0.2 kilogram of water inside the glass. What will happen to the mass of the water after a week? Will it increase, decrease, or remain same? The mass of the water, will it increase, decrease, or remain same? That's a question. The beginning of the experiment, it was 0.2 kg. But after a week, some of the water evaporates. What will happen to the mass of the water which is remaining? I'm waiting for the response. Yes, Abdullah Khan, Heather, Abdullah Sarfraz, Saim. What will happen to the mass of the water which is left after 7 days? That's the question. Will it increase, decrease, or remain same? So basically what happened, the correct answer, the mass of the water will, in this example, it will decrease. Or it will be less than 0.2 kg. But why it will decrease or it is less than 0.2 kg? Because the amount of the matter will change. This is, like example, was a liquid. So when the amount of the liquid was more, it was having greater number of the particles in it. But as the liquid, as the water molecule or in a liquid evaporation happen, so these particles escape, they come out. So what happened to the amount of the matter? The amount of the matter is decreasing. So as the number of the particle and amount of matter decrease, then the mass will also decrease. Is it clear? So during evaporation, as the amount of matter or number of particle decrease, the mass of an object will also decrease. That's why, like example, when you are doing excessive exercise, so when you sweat, basically the matter is coming out from your body, and that matter causes the decrease in mass of the athlete or the runner body. So mass remain constant if the matter remain constant. If the amount of matter changes, the mass of an object will also change. And mass of a body is resist to the change in state from rest or motion, and we call that as inertia. Basically inertia, the definition of inertia means it's a property of a body to resist the change in state. When the body does not change its state easily, we call it is having inertia. So example, you have two boxes, one is 2 kilogram, another one is 20 kilogram, and both are stationary at rest initially, and 20 kilogram, and you're applying a force, you're trying to push them. Which object is easy to move? A or B? Which box will be easy to move or push? A or B? So in this example, A will be easy to move, or we can say A can easily change the state, or we can say it is having lower inertia. Where for B, it is having a greater mass, so it will be difficult to move, or change the state. So we will say it is having a greater or higher inertia. So basically, inertia is a property of a body to resist the change in state. The definition of inertia: the property of a body to resist change in state, and heavy objects have greater inertia than lighter objects. Because heavy objects are difficult to move, lighter objects are easy to move. So basically the concept of inertia is a tendency to resist the change in state. Like if something is at rest and you try to apply a force and try to move it, so why the object does not move easily? Because it is having a mass, or it is having a matter, or we also say it is having a inertia. So greater the mass, greater the inertia of an object. Same way, if you have two objects which are moving with the same speed but different masses, like this is a 5 kilogram object which is moving with the speed of 2 meters per second. This is 50 kilogram object moving with the speed of 2 meters per second. Object A and object B. Which object is difficult to stop? Two objects, one is having a mass of 50 kilogram moving with a speed of 2 meters per second. Another object of mass 5 kilogram moving with the speed of 2 meters per second. Which is 5 kilogram is object A and 50 kilogram is object B. The question is, which object is difficult to stop? So B is difficult to stop. So we can say this is having a higher inertia or greater inertia. And this is having a smaller inertia. Because here we find it difficult to change the state, and here we find it easy to change the state. So basically, inertia is a property of an object to resist the change in state, and greater the mass, greater the inertia. Is it clear, the concept of inertia of an object? So that's the same statement written: a body is resist to change in motion due to greater inertia. That's why heavier objects are difficult to stop when they're in motion as compared to lighter object. And mass is a scalar quantity. When we say is a scalar quantity, it means it does not have direction. A quantity without a direction having magnitude and unit, that's called a scalar quantity. So quickly I'll revise what we discussed about the mass. It's a measure of matter, how much particles or amount of matter. SI unit is kilogram, and it can be measured by a beam balance or electronic balance. mass of an object remains same until the number of the particles are same. If the number of particle changes, the mass will change. And the heavy objects have greater inertia as compared to lighter objects. Then what is the concept of the weight of an object? Weight of an object is attractive force exerted on it due to gravity. So different planets have different values of the gravity. So how much force these planets are applying on the object, that force is called a gravitational force. For example, you have Earth, Moon, and Jupiter. So you place an object here, a 1 kilogram object on Earth. You place 1 kilogram object so we place 1 kilogram object on the surface of the Earth. We place 1 kilogram object on the surface of the Moon, and we place 1 kilogram object on the surface of the Jupiter. So what these planets have the tendency, they have a gravity. The force is there which is attracting the objects towards the center, that's called the force of gravity. So all these objects which are placed on the surface are experiencing a force, and that is directed towards the center. So the force by which these planets are pulling the object, that force is known as the gravitational force, or we can also say weight of the object. So the force by which Earth is pulling us on towards the center, we call that is our weight. Same thing, the force by which the moon will pull us towards its center, we call the weight on the moon. And the force by which the Jupiter will exert force and pull towards the center, that is also known as weight of the object. But weight of the object changes from place to place. Why it changes from place to place? Because different planets have different gravities. Like the value of the gravity is not same for the planets. It changes with the size of the planet. As a planet is having a greater size, then it will have a stronger gravity, or more particles are there on the planet, then it will have a stronger gravity. So the gravity, the strength of the gravity of Earth, that is 10 Newton per kilogram. What does it mean 10 Newton per kilogram? It means if it is 1 kilogram object will feel the force of 10 Newton on Earth. The gravity of the moon is 1.6 Newton per kilogram. So what does it mean? It means if we have 1 kilogram object on the moon, that will feel the force of 1.6 Newton. And the Jupiter, gravity of the Jupiter is 25 Newton per kilogram. So what does it mean? It means that if we have 1 kilogram object, that will feel 25 newtons on the surface of the Jupiter. So stronger gravity means more weight will be there. So if we have an object, a 1 kilogram object, if there is 1 kg object on the Earth, so the gravity of the Earth is 10 Newton per kilogram. So what does it mean? It means that if we have 1 kilogram object, it will experience 10 Newton force. So what will be the force of the gravity or the pull which this object will experience on Earth? That will experience 10 Newton. So we will say weight of 1 kilogram object on Earth is 10 Newton, because the force by which the planets are pulling the object towards the center is known as the weight of the object. Same way, if you have 1 kilogram object on the moon, so if 1 kilogram object is placed on the moon, the gravity of the moon is 1.6 Newton per kilogram. So that 1 kilogram will experience a force of 1.6. So that will be 1.6 Newton. So weight of the object, 1 kilogram object is 1.6 Newton on the moon. That's why the object appeared to be lighter on the surface of the moon as compared to that of Earth. And if the same 1 kilogram object is placed on the surface, Jupiter is a gas giant, it does not have a like hard surface, but example, if it was placed on the surface of the Jupiter, then the gravitational force of a Jupiter is 25 Newton per kilogram. So this 1 kilogram object will experience 25 Newton. So Jupiter will have a strongest force, that's a stronger gravity, so object weight will be much higher as compared to that on moon or on Earth. But what will happen if we have 2 kilogram object? Like first we took example of 1 kg. Now if we have 2 kilogram object, so what will be the force of the Earth on 2 kilogram object? The gravitational force. So if 1 kilogram object is experiencing a force of 10 Newton, then 2 kilogram object will experience a force of 20 Newton. So it will be double. So greater the mass of the object, greater the weight of an object. Same way, if we place a 2 kilogram object on the surface of the Jupiter, so how much force it will experience? If 1 kilogram experiencing a force of 25 newtons, so 2 kilogram object will experience a force of 50 Newton. So greater the mass of an object, greater the weight, and the formula which relate the mass and weight together, that is equals to W is equals to mg. So weight is equals to mass multiplied by gravity. This is the formula which relate mass and weight. W equals mg, where W is equals to weight, m is equals to mass of an object, and g is the gravity of that planet, depending on if in a question they mention as say Earth, then you will take gravity as 10. But if it is moon, then the gravity will be 1.6, and for Jupiter it will be 25. So in short, the concept of the weight is the gravitational force which the object experience, that is known as the weight of an object. And the SI unit of the weight is Newton. And how we can measure the weight, or how we can calculate the weight, find the weight, we can use these balance known as the spring balance. These balance are also common, you have seen. So these are known as a spring balance, which are used to measure the weight of an object. And weight of an object vary from place to place. It depends on the gravity. Like example, you have one object on Earth and another object on the surface of the moon. Yes, we can use them to measure the mass, but practically it is directly used to measure the weight and then used to convert into mass. But the calibration is there. In a everyday life, you're using it to measure the mass instead of weight. So example, we have a 1 kilogram object on Earth and we have 1 kilogram object on moon. So, and the gravity of the Earth is 10 Newton per kilogram. So how we can find the weight on Earth? The formula W is equals to mg. So m is the mass, which is 1, multiplied by gravity of the Earth is 10. So 1 multiplied by 10, that's equal to 10 Newton. So weight of this object on Earth, the gravitational force, the pull of the Earth is 10 Newton. You take the same object on Moon, the gravity of the Moon is 1.6 Newton per kilogram. So how to get the weight of this object? That is mass multiplied by gravity. So mass is 1 but the gravity is only 1.6. So you will get as 1.6 Newton. So the weight of this object is only 1.6. So two objects have the same mass but they may have different weights depending on the planet or the place where you are calculating the weight of an object. Is it clear? So weight of an object is not constant, it changes from place to place. This is a formula which relate mass and weight together. W is equals to mg. If you need mass, so it will be weight divided by gravity. So it's the same formula, W equal mg. If you need mass of an object, it will be weight divided by gravity. And because weight is having a direction, so weight is a vector quantity. And the value of the gravity decreases. Like example, on the surface, two objects are there. One is on the surface of the earth, another one is at a certain height above the earth surface. Which object is heavy, A or B, if two objects have the same mass? Weight is always acting downward. That's why we normally do not write the direction. We simply say, because weight is always acting towards the center. So it is obvious, that's why it's not normally written. But it is always having a direction towards the center. My question is, which object, if two objects are there, each object is 1 kilogram. This is 1 kg object, B is also 1 kg. Which object is heavy, A or B? So which object is having a greater weight? The correct answer is A. Why A is the correct answer? Because the value of the gravity decreases. On the surface, the value of the gravity is 10 Newton per kilogram. But when we move away from the surface, the gravity is weaker. Like here, the gravity of the earth might be 10 Newton per kilogram. So gravity of the planet on the surface, it is maximum. And as we move away from the surface, the gravity is weaker. That is why you will see, like astronauts or International Space Station, you will find that astronauts in an International Space Station, they are floating easily because the weaker gravity make them move easily or float easily. Is it clear? So weight of an object changes as we move away from the surface. It decreases as the gravity is getting weaker. Any question till now? Less than a minute left. So any question or a doubt? I'll share another link and continue the discussion.